Like all cheeses, mozzarella starts from milk. To assure good milk quality, the interior and exterior of tank trucks transporting milk must be washed after being emptied. A tank such as this one can carry an average of 30,000 liters of raw milk at a temperature of 3 or 4 degrees centigrade. Raw milk destined for cheese making contains 3.8% fats and 3.3% proteins. They store the milk and whey, a milk byproduct, in these immense silos, each with a capacity of 225,000 liters. This milk separator extracts surplus cream to adjust the percentage of fat according to the type of cheese to be made. Fabrication begins with this tank, which feeds the pasteurizer. Pasteurization sterilizes beverages which can easily ferment. Milk samples are drawn off to precisely determine their milk fat and protein content. Tests are carried out in this laboratory where they impose controls. These test tubes contain milk samples which will undergo microbiological analysis. Milk quality must be impeccable. This is a curdler with a 25,000 liter capacity into which milk and other essential ingredients for making mozzarella are introduced, such as the enzyme rennet that curdles the milk. This mix must be well stirred and cooked. The agitators are used to cut the whey into little lumps. This step takes about 30 minutes. The temperature of the tanks depends on the type of cheese they're making. Agitators continue stirring the milk. Once cooking is done, the whey is pumped onto tables to be drained. It stays there for about 25 minutes. The solid and the liquid are now well separated. The liquid we see draining is called lactose serum. The lactose serum will be concentrated and transformed into milk byproducts. The water has been almost entirely extracted and the cheese particles are now sufficiently dry. This large automated blade then moves cheese particles towards the next step. That is, toward the molder. In the molder, the cheese is cut up before being carried to the cooker, the final processing step. It appears that this mozzarella has just the right texture. The cheese finally arrives at the molder, which will give it the proper shape. Each mold has a 2.5 kilo capacity and is rectangular. Brine, a salt solution, serves to cool as well as to salt the cheese blocks. The blocks are unmolded and fall into a brine tank. Following on, the cheese blocks will remain in another brine solution for a while. They are then carried by a conveyor towards another tank, where they will be immersed for 4 to 10 hours at a temperature of 2 degrees centigrade. Sprays of brine remove the foam which forms at the surface of the tank. The 30,000 liters of milk that we saw coming in by truck at the beginning have enabled them to produce some 1,400 blocks of cheese in only 8 to 12 hours. The cheese blocks are finally vacuum-packed, ready for shipment.
The bowling ball has undergone a lot of changes over several centuries to become such a striking success. From a crude stone to carved wood to rubber to molded polyester, it's been reinvented numerous times. But the latest version has turned out to be a real winner. Technological advances have reshaped the bowling ball at its very core. No longer round, the nucleus is asymmetrical, which causes the ball to curve towards the pins as it rolls down the lane. They make the cores from polyester resin, blending in minerals like barytes, silica powder, and limestone. The result looks like chocolate milk, or make that hot chocolate, because a catalyst triggers a chemical reaction that heats it up. As they pipe it into the molds, it quickly starts to cure and solidify. In just 2 minutes, it's ready to extract. This core is oblong, flat on one side with a knob. There are different versions of this core design, each one carefully calculated to manipulate the bowling ball's performance at a specific skill level. They now drill towards the center of the core to make a pinhole. This allows the core to be suspended in just the right position in a second mold. This asymmetrical core is about to be encased in a more uniform sphere. They tamp the core into the bottom part of the mold and then lock down the top half. After all, they don't want any leaks as they pump it full of plastic. It's a liquid polymer blend. A special chemical in it causes the mix to solidify slowly. It can take days for it to harden around the core, depending on the formulation and type of bowling ball being made. When they knock it out of the mold, all is revealed. That asymmetrical core is now sealed in a very symmetrical polymer shell. Next, it's into a third mold. This one will seal the bowling ball in an outer skin called the veneer. This veneer has been scientifically formulated to enhance the ball's traction as it hooks towards the bowling pins. It's made of colorant, plasticizer, a chemical called ISO, and urethane. Blending these ingredients produces high-performance polyurethane. As the mix flows into the molds, a chemical reaction causes it to heat up and solidify in just seconds. Then it's into an oven to boost the chemical reaction. Next, a spinning grinder shaves off the bump which was formed by overflow at the mold's intake tube. The removal of this bump rounds off the shape of the bowling ball. With its 3 layers, this bowling ball looks a bit like a big bonbon when it's sliced in 2. And while it may look sweet, it needs a bit more work before it's ready to take on the competition. A lift system delivers the bowling ball to a sanding operation, which roughs up the surface. The coarseness of the sanding varies, depending on the performance goals of the particular ball. This machine heat stamps trademark information onto the ball. They do one last sanding as a constant flow of water removes the powdery residue. The more polished the surface, the less pronounced the ball's hooking action will be. Even this last sanding is geared to a certain performance standard. Once they buff the surface, all that's left is to custom drill the finger holes. With this bowling ball in hand, success should be within striking distance.